Hello, good morning, good afternoon, good evening, wherever you're watching me from. Today, I come your way with a very wonderful episode. It's going to be a series on reinforced concrete design. My name is Daniel Ike. Please, I would like you to subscribe to this channel and get ready for us, because this time, if you're an engineer, if you're a builder, if you're an architect, and you wish to learn reinforced concrete design so that you can know the basics, even though you might be using software for your concrete design, but you will find it very rewarding if you can know the basics or the nuts and bolts of design before implementation with your designing application, talking about Orion or Brutal structure, etc. So today we go right into what we have for you, and let's see how far we can go. So we are going to be talking about a few things. Number one is introduction to our reinforced concrete design. We're going to talk about compression. We're going to talk about tension force, the difference, the similarities, and the design objectives. These are just foundational teachings to get us started for what we are set to do in this period. So sit back and listen and enjoy the lesson. Now, what is reinforced concrete? Reinforced concrete is combination of two dissimilar but complementary materials, namely concrete and reinforcement. In case you are just new to these things, you need to get this straight. Concrete structures, talking about structures or members, are subjected to forces of tension and compression or shear force. When you talk about elements of structures or members of structures, we are referring to no other things than the slab, the column, the beams, foundation, part foundation, all of that, all the components of the building. These are the three forces that come to play. The first one is tension. Tension is the stretching or pulling, a pulling force that tends to pull a material apart, which causes cracking, spalling, and ultimately structural failure. You will notice that the beam you see in display is being pulled by two opposing forces. That's tension. It will be very practical to understand that, like we have established, that members or elements of structures are subjected to these forces, three forces. And the first one is tension force. The second one is compression force. Compression force is a force that tends to crush a material, causing it to deform or to densify it. So these are two opposing forces acting in opposite direction. When it comes upon a body, it tends to crush it or densify it. The word densify would mean to make it, kind of denser, to increase the density of the beam. Then we'll move on. We talk about shear force. Shear force is the kind of force that causes an object to deform by sliding or rotating along a plane that is parallel to the plane of applied force. So we understand that tension force is the one that pulls the material apart. Compression is the one that presses and tends to squeeze in the material or the member of the object. But shear force is one that causes sliding or rotation along the plane. We're going to make a few comparisons so that we understand, what shear force is. It tends to shear the member or the element or the object because it acts perpendicular. You can see that line there. It acts perpendicular to the axis, the longitudinal axis of that object. So you can see it there. So moving on, I want to look at the differences. We want to look at the differences and similarities. The differences and similarities between these forces that come to play. Like I told you, compression and tension, they act along the longitudinal axis of the plane, okay, while shear force acts perpendicular to the plane of application. So what we are saying in a nutshell is that if we have a beam or an object like this, the force that tends to crush the object is called compression. The one that tends to pull the object apart is tension, and the one that tends to share it along or perpendicular to the longitudinal axis of the object. This is the longitudinal axis of the object. So it acts perpendicular. It's always perpendicular to that. So causing it can act from this side, it can act from this side. So in a member like this, because we are talking in terms of structure, the organized network of framed structure, the beam on the column. So if this is understood to be the column, it can introduce a tension force on this member as a reaction force. So when you understand these forces, it will inform what we are about to say in terms of reinforced concrete design. So I hope that meets you well. Okay, moving on. So we now talk about another similarity. Or differences rather. Compression tends to decrease the length of an object. Tension tends to increase the length of the object, beg your pardon, while tension causes deformation without affecting the volume. Compression affects the volume because the density has been affected, and the tension force also stretches the object and increases it in length like we've seen. But shear does not increase the volume. Continuing with our lecture, we are talking about concrete and steel, reinforced concrete design, but we need to build up to these things. Concrete alone is good in compression. If we are only dealing with compression in the building, we will use only concrete. But concrete is not good in certain areas. It's not, we're saying, if we are only dealing with compression, concrete would have been enough. But like I said, in concrete structures, in reinforced concrete structures, members or elements of the structures are subjected to forces of tension, compression, and shear forces. So concrete is good in compression. It is incompressible. That is where we got the concept of crushing strength, which is the force, the crushing strength that the concrete can resist in the crushing strength test of concrete. We'll come to all of that. So, but it's fair in shear. It's not too good in shear force, in resisting shear force, but offers little or no strength to tension. So concrete, once you pull it apart, it snaps. It's not very good in tension. I hope that helps. Steel is good at compression if you compress steel, but concrete is best for it, but steel is good at compression, tension, and shear. Steel has poor resistance to fire due to rapid loss of strength under high temperature. Like we said, concrete is good in fire resistance, but steel does not have that much resistance to fire. It tends to lose its strength rapidly under high temperature. So this difference in character complements each other in carrying out their function in making the structure to be stable. So they are different, but they are complementary. That is why we have reinforced concrete. So that will lead us to talking about reinforced concrete design with some of the foundations we have been able to lay. Thus, these varying characteristics, like we say, of steel and concrete necessitates the combination of both, which result to reinforced concrete that has good tensile compressive strength, durability, and good resistance to fire and shear force. I hope that meets you well. The knowledge of the forces present in the loaded concrete members make it important that it is not just enough to reinforce the concrete members, but to know where to position the reinforcement bars in the sections. So it is not just enough to get your concrete and put your steel, pour it, and no. There are specific way you have to lay reinforcement because of what I'm about to show you. Now, take for instance, we have a beam this way, and this simply supported beam. Okay, so there is a region of this beam. Let me be more clear. So this is what we have right now. So let's assume this is columns. Okay, beam supported by columns, simply supported beam. Okay, so what we are trying to establish here is that a portion of this beam is subjected to tension. A portion of this beam also is subjected to compression. So this zone, let me let me change this zone. This side of the beam is subjected to tension. Then this side of the beam is subjected to compression. So that's what we're saying. So that will make you now to design for tension steel and compression steel, and you know where you position them in the member. So this is tension steel because you want this portion that is under tension to be able to resist the tensile steel. So simply supported beam, this is the theoretical deflection of this beam. So once it aches like this, you know that the beam has deflected. And because of that, you'll find that the back of this place, because of the way it's being stretched, and this region is under tension. So the upper side is under compression. So what do? You design for both tension and compression, and also shear reinforcement. I hope that meets you well. So that's what we're talking about. Moving on, like we said, to bring a pictorial recap of what we have established. This is a simply supported beam. Shear force, like we say, acts perpendicular to the longitudinal axis of the member or the element. And coming to my right hand side, you have the top zone of this beam is under compression. The bottom zone is under tension. And so reinforced concrete design, we see to it that there is a reinforcement placed very close to the bottom of the beam so that it can counter the effect of tension, because we say that steel is good in tension. So don't be carried away with all of what we're saying. We appreciate it in the next teaching. Why I said what I've said. Another one is cantilever. You see that this cantilever is under tension on the upside because there is no support at this level, and so the tension capitalizes on top. So the main reinforcement bar should be placed close to the top, which is why I told you it is not just to know you have to use reinforcement in your structure, but to know where to place them in order not to make it a waste. And so this is the section of any of this beam, or of this particular beam. And you see compression at the top, you see the compression steel, the black dot, and you see the tension steel, so at the bottom level. So this is what we have been saying about the three forces that come to play in a structure. You can see that. The method of determining the magnitude of the forces in a concrete member, the size of the concrete section, the quality and the quantity of steel combined safely and in an economic way is what reinforced concrete design is all about. Remember, I told you it's not just about knowing that you have to reinforce the concrete, is to know where to place the reinforcement concrete. It's not just to place the reinforcement bars. It is also a question of where to put this and what quantity to put this reinforcement. So we understand that the method of determining the magnitude of the forces in the concrete member, the size of the concrete section, the quality and the quantity of steel combined safely and in an economic way is what we refer to as our concrete design. So what is reinforced concrete design? It is just the safe and economic way of combining concrete and steel in order to serve the purpose. So we continue. What are the design objectives? What are the things that should form your objectives when you are designing a reinforced concrete member? Number one, under the worst loading condition, the structure must be safe. The structure must be safe. Under the working load, the deformation of the structure must not impair the appearance. It must not impair the durability and the performance of the structure. Number three, the design should ensure that the structure is economical. The objective of design is safety, durability, and economy. The method of achieving these three objectives is called reinforced concrete design. So under any kind of worst loading scenario, the structure should be safe. So what ensures that? Reinforced concrete design. under the working load, the deformation of the structure should not impair the use of that structure. Yeah, you should also ensure that materials are not lavished because you want to achieve strength, and then you over design. So these are the three objectives of design. These are the three objectives of design. So we want to go into theory of structure, so that we can do certain things about, and this will come in our next teaching, so that we can know some of these things before we now enter into what we have for the series. Thank you very much.
So, by way of encouragement, I will ask you to subscribe to the channel, take your seat, and fasten your belt, because I am the captain, and I promise to take you to your destination as we proceed in this series. So call your friends or whoever that may care, or you share the video to the person. So if you're interested, you follow on to know the next thing on the series. We are going to design many things. We are going to design high-rise building, but we need to lay foundations on some of these things so that people who are joining later will not find it strange. They will know where we're coming from and where we are and where we are going. God bless you till I come your way next time. Bye.